Good day, everyone. This is Abdullah, and I'm going to be presenting on DeVault. So basically, DeVault is our submission for ICHL. It is a decentralized platform for storing and verifying documents built on the internet computer. So the core idea is simple. How do you prove that a document existed at a certain time without trusting a central server like Google Drive or Dropbox? So things like contracts, like certificates, like IP protection. So I'll just walk you through how this works, the architectural design and the code. So basically, this is the architectural design. So basically, it works with three main parts. So the user design, the user device, that's the front end. So the canister and the IPFS storage. So basically, that's how it works. So the user front end handles the UI, it hashes the file, it swaps to IPFS and the canister, so with functions. So the canister is a Motoko smart contract that stores metadata in stable memory, and authentication is handled via internet identity, so no need for passwords or other Web 2 verification methods. So internet identity handles the authentication. So yeah, IPFS handles storage, internet identity handles authentication, and canister handles verification. So that's it. Very cheap, distributed, and centralized. Okay, so let me just walk you through the user flow. So a user clicks login, is logged in with internet identity, no passwords, just cryptographic principles. And when they want to upload, the file is hashed in the browser, is uploaded to IPFS, and the metadata is stored in the canister. So basically, that's how it works. And when they want to verify a file, so anyone can check if a document hash exists. No login, just a quick query with the file hash, the file hash, and they can verify and validate a file. So it's lightweight, decentralized, and very easy to verify, even many years after it has been uploaded. So these are code base here. So let me just walk you through some core files. So first of all, this is the state. This well, basically it's a monorepo divided in front end, back end, as usual as it should be. So let me just walk you through some key code. Yeah, so this is stable. These some state variables for stable storage. So this allows our data to survive upgrades, and hash maps allow us to do quick in-memory access during runtime. So as for the other parts like store file, so this store file function allows us to actually store the files. So the message, the MS, the caller here is automatically verified. Is no tokens, no sessions. It just allows us to identify the person uploading from internet identity. So there's also, as I said earlier, everything is based on hashing. So the files are hashed both client side and server side, and if they don't match, we reject it. So it allows us to ensure data integrity. So there are also types. So these types allow us to be consistent. It allows us to know what to expect in runtime. So, and Motoko enforces that all of them are handled, so there are no silent failures. So there's also I think verify file. So yeah, this verify file basically does what it says. It verifies if the file is authentic. So with the hash that we mentioned earlier, that anyone can use to verify the authenticity of a file. Yeah, so no need to log in, just a quick query, and that is, and it's done. Yeah, so as for the front end, there are also logic in the front end. For example, remember that I mentioned that we also hash the file on the front end first. So this is it, using the Web3 crypto API. So it handles the hashing securely, yeah. So there's also state handling that allows us to handle authentication file upload and display functionality. Yeah. So I think this pretty much says it for all of our projects. So basically, it runs on a React front end and runs with Motoko on the back end. Yeah. So just for more context, in the real world, this will be really useful. For example, for legal documents, for example, you can always verify and validate the time with timestamps, the authenticity of legal documents. So as for example, yeah, academic credentials too. Instead of having to call the school, you can just verify with the hash ID to know if it is authentic or not. So it also goes beyond that to IP proof of originality for digital art, writing code, and so on. So it basically gives users cryptographic proof without needing a lawyer, without needing an admin, or without needing a central database. So basically that's what canisters do best: verify and persist. And IPFS helps us handle the storage. So yeah, so that's it for DeVault. No need for server, no need for database, no need for third-party authentication. That's handled by the internet computer. So with this, we can verify millions of documents without breaking decentralization. Um, yeah, so this basically just shows how we can solve real-world problems with blockchain without unnecessary complexity. So I hope this has been an enlightening session about DeVault. DeVault is Web3's decentralized file storage and verification platform. So thank you for listening, and I hope this was enlightening.